Back in the days of Charles Darwin, relatively little was known about the complexity, the enormous complexity of the microscopic world, the microscopic aspects of living organisms. There was a view that in the latter part of the 19th century that a living cell was essentially a featureless bag of enzymes, all kind of in true solution. Not much in the way of detailed three-dimensional complexity. But of course in the 20th century we've made enormous strides in understanding that that's not the case at all. There is a very great degree of intricacy of architecture down in these cell units. So today everybody understands about bits and bytes, and so perhaps a useful illustration there of the complexity, let's say, of the DNA molecules might be helpful. You can calculate the number of bits contained in tightly packed DNA material, let's say, that would fill 1 cubic millimeter of space, as equaling 1.9 times 10 to the 18th power bits. Now that number is by many orders of magnitude vastly greater than the storage capacity of the largest computing machines that we have, the supercomputing machines. Their storage capacity per cubic millimeter is far less than the information storage capacity in the DNA molecule. Now, moreover, the DNA itself, as it functions in a living cell, has about 100 different proteins involved with just its own functioning. And then you have these tens of thousands of other proteins in the rest of the living cell also involved. So we have now a picture of immense submicroscopic complexity, and so it no longer is a reasonable proposition to think that simple chemical events could have any chance at all to generate the kind of complexity that we see in the very simplest living organism. So we have not the slightest chance of a chemical evolutionary origin for even the simplest of cells now, with the new knowledge that's accumulated in this century.